Hello, and thank you for downloading this latest Data Science Central podcast. This is Rafael Knuth, your host. I'm a contributing editor with Data Science Central. Today's podcast is sponsored by SAS. We very much appreciate SAS's support of the Data Science Central community, and we are honored to have them sponsoring our event today. This podcast will be about 15 minutes long, and we have one speaker who I'll introduce in just a minute. Today's talk is entitled AI, Extracting the Hidden Value in Unstructured Data. And our speaker is Tuba Islam. Tuba is a data scientist at SAS. She enjoys telling data-driven stories and designing analytical solutions to solve complex business problems in simple, creative, and effective ways. Tuba specializes in machine learning, deep learning, forecasting, and text analytics. As an analytics consultant, she had the opportunity to implement interesting projects across various industries. She has an electrical engineering background and holds a master's degree in digital signal processing. Tuba, thanks for being with us today. With the help of natural language processing, NLP, AI solutions can automatically extract critical business insights and emerging trends from large amounts of structured and unstructured content. Join this podcast to hear the benefits and challenges of NLP and understand SAS's hybrid approach to the technology. You will also learn about use cases. Tuba, with that, I'm going to turn it over to you. You can begin as soon as you're ready to go.
Thank you, Rafael. Unstructured text is the largest human-generated data source, and it grows exponentially by minute. By the end of this podcast, there will be almost another 8 million tweets posted. And it's not about only the social media data. Even more valuable data is stored in the data sources within the organizations. In healthcare, for instance, medical records include free-format notes entered by the caretakers, and these notes could be analyzed to find discrepancies in the diagnosis and provide a second opinion to the practitioners. Another example in insurance, the notes for claims can be used to improve fraud detection models and generate alerts. Or contact center notes, surveys, CRM comments. They can all be used to understand what the customers are talking or complaining about. These all include valuable insights to improve the operations, customer satisfaction, or the treatment of a patient. However, it's not that easy. When we move into the world of unstructured data, we face different challenges. Languages are inherently messy. We need to process large volumes of data and inconsistent formats, and sometimes not even in digital format, but on paper, or maybe in an audio source. Another challenge is the variety of the languages, and also misspellings, abbreviations, slang. The subjectivity can also be tricky. The interpretation of text could differ depending on the reader's point of view or background. Handling these challenges would be time-consuming, and that's why majority of the organizations leave the unstructured data aside. The huge potential value that could be unlocked just sits on the disks without being touched. This is very sad from a data scientist point of view, and we can change it. Using today's technology, we can automate the process of reading, organizing, and quantifying the free-form text in a meaningful way. In simple terms, using natural language processing, we can create a structure from the unstructured data. We can either extract something we search for, or we can discover totally new, unknown information which can be even more valuable. Natural language processing is a branch of artificial intelligence that focuses on the understanding, interpretation, and emulation of human language. NLP draws from many disciplines, including computer science and computational linguistics, and becomes the bridge between the human communication and the machine understanding. Here you see the key activities handled by NLP. Text analytics with NLP is an iterative and domain-specific process. For a successful project, there are three key elements. We need the right technology, the domain expertise, and of course the text data. Here you see an end-to-end flow. SAS offers the ability to use both machine learning and linguistic rules for processing text, which makes it powerful. The output of text analytics can vary from topic discovery to entity or keyword extraction to categorization, sentiment analysis, and this output can then be fed as input into other models. For instance, we can perform predictive analytics for maintenance and use the output of engineering notification notes to predict the failures of machines in advance, or provide operational insights for churn or fraud analysis. Or on a totally different topic, we can create conversational systems to interact with information, such as chatbots. With this hybrid approach, human expertise with linguistic rules provides the guidance for accurate analysis, and machine learning with supervised or unsupervised methods helps the analysis scale with ease. When using natural language processing to analyze data, the machine first must split the unstructured text into useful and comprehensive units. This is called tokenization. Then the following steps would be parsing, applying linguistic analysis to extract features from the text, such as the stems, the roots of the words, part of speech, noun groups, sentence boundaries, and many more. In addition to machine learning, the deep learning models, such as recurrent neural networks, can be applied for time series forecasting, text generation, speech-to-text, and other NLP tasks. Something to mention here, for the use of the supervised techniques, the data will need to be labeled, and for unsupervised models such as discovery topic or clustering, we don't need those annotations. A key challenge I mentioned was the variety of languages. Especially for multinational organizations, this can be a big challenge. Imagine how it would be if you could understand 33 different languages, and you can do it with SAS. Linguists that know the distinction in syntax and semantics of the languages are critical in developing NLP capabilities. And NLP needs to operate at scale and speed. This is the speed that people expect AI systems to perform. SAS has a team of linguists around the world who provide that human expertise in developing NLP capabilities. Here is the list of current languages with out-of-the-box NLP functionalities. Now, let's look at a customer use case for contact center analysis in a large telecommunication company. This would be applicable to any organization that runs a contact center. Today, customers expect their interactions with companies to be simple, intuitive, and efficient. And they want an immediate response, whether they are on website, on web chat, or calling the contact center. With a high volume of customer service calls, emails, and social media messages across 4 languages, the company was struggling to respond to customers quickly and provide an effective solution at the first point of interaction. With 10,000 daily service requests, staff were manually analyzing, routing, and assigning actions to meet each customer's needs. And the result was poor customer satisfaction and negative sentiment on social media. SAS text analytics enabled the company to analyze the contact center transcripts to provide a richer picture of customers' needs, make more relevant and customized offers to help retain customers in an increasingly competitive market, and also interpret customer feedback across multiple communication channels in 4 different languages. Customer service representatives can almost simultaneously transcribe a customer call and quickly categorize a problem, assign a severity level, and then recommend a solution to improve customer satisfaction. So how does that work behind the scenes? I will talk about a few highlights of the SAS text analytics solution. The first one is about collaboration. SAS makes the NLP process simple so that it will be possible to enable more people within the organization to extract insight from text. You don't need to be a hardcore programmer. And it's totally fine if you enjoy and prefer coding, because the tool has programming interface as well. But if you fancy GUIs and want to get quick results with automation, you can benefit from this environment. The tool has out-of-the-box best practices so the users don't need to start from scratch. And even better than that, they can save their pipelines, whatever they created, into a centralized exchange location to share with others or reuse in the future. Text parsing is another important feature with the support of 33 languages for stemming, misspell checking, part-of-speech analysis, filtering, etc. in an interactive way. Automatically generated out-of-the-box concepts also give a head start to the users. These predefined concepts like date, time, location, person, money are standardized across all languages. Another nice aspect of automation is allowing the users to automatically generate rules by selecting the keywords they want without the necessity of knowing the syntax. The users can also discover hidden topics interactively with machine learning using the unsupervised approach. And finally, the scoring code is immediately available once the model is run and ready to be executed either in batch or in real time, on cloud or on-premise. Now I will show a short interactive demo to highlight a few of these capabilities. We will work on a healthcare scenario and analyze a publicly available adverse event data for vaccinations. The goal is to understand the reactions of patients after the vaccinations and create a structure from the case notes of the practitioners. We are looking for adverse events in the documents. The very first and simple approach would be using the search. It's a good start, but we want more than just a search. We want to use the power of NLP and automate the process of extracting entities. I can start with creating a new project and first choose the language of interest. You see the list of 33 languages here, including German, Spanish, Tagalog, Turkish. Then I can go into the pipeline template repository and choose a built-in or saved pipeline instead of starting from scratch. Here is the data. I will analyze this symptom text field and the pipeline. I will go into concepts directly to show some of the automation capabilities. Here you go. You see on the left-hand side the predefined concepts. Date is one of them. It highlights the matched terms at the bottom. And you see these are not standard date strings, but much more complicated than that. So I can extract the matched text like the following day, a couple of years ago, the next day, etc. These predefined concepts are standardized across all languages. And I can also create custom concepts, like a simple classifier rule for body parts. And within this interactive GUI, I can improve my linguistic rules automatically without writing any code or even knowing the syntax. I noticed the term malaise, for instance. It wasn't highlighted, but I want to include it in my rule. I just right-click, add to the rule, and here you go. It's updated. I can also generate a new rule from the selected terms. So I will search for headache, head-related severe symptoms. I can check the terms and click the create button, and it will give me the options, and I want them to occur in the same sentence. And without knowing the syntax, using the drop box, I can create a brand new rule. I can also generate new rules using the labeled data using auto-generate option. These automations can enable more users to process text and also help them gain insights quickly and efficiently. I can now explore the outputs of my concepts model in the integrated exploration environment, see the high frequency of reactions for age over 50 and female. I select that group, and it applies a filter on the matched text. And the ones that visit emergency are the most costly, so I can understand the reasons of their visits and make further explorations. That was all for today's podcast, and I hope you enjoyed watching.
Tuba, thanks for that excellent presentation. I have a few questions that I'd like to ask based on your presentation, if you don't mind. So my first question is, you mentioned the detection of unknowns. How can the tool find something that is unknown?
Yes. Well, the machine learning algorithms help us find it. With the discovery, the topic discovery, for instance, the unsupervised algorithm automatically classifies the documents into topics and describes each topic with some selected keywords. So as a user, I can go and look into those auto-generated topics and notice something brand new. In a recent project for a pharmaceutical company, we were analyzing the social media forums to detect the drug abuse, the posts about drug abuse. And on a side topic, we noticed an interesting one on complaints for the availability of the product. Apparently, the drug was not provided to some regions in the US due to a problem, an issue in the distribution system, and we could detect it automatically without knowing anything about it, which was very valuable.
Awesome. Tuba, I have one more question. How much business input is needed? What kind of team do we need to set up?
Having a diverse team with both text and domain expertise is the best practice, I would say. In text projects, sometimes you search for a needle in a haystack, and the supervision of a domain expert not only takes you to your destination, but also saves a lot of time on the way. So it's very, very beneficial.
Tuba, thanks. That was a very interesting discussion. I'd like to thank again SAS for sponsoring today's Data Science Central podcast, and particularly our speaker today, Tuba Islam, for her insight into today's topic. My name is Rafael Knuth, and I'm very pleased to have been your host for today's event, and I look forward to seeing you all again on Data Science Central's next podcast. Have a great day.